Hi, good afternoon, everyone. Thank you for this amazing panel and thank you for introducing us and hosting us here. Peter, our partner in this project, he will unfortunately not be able to join us today, so it will be me and Umar presenting. Um, so our project revolves around the the quest for creating a text recognition model for Arabic script historical manuscripts, including manuscripts in Ottoman Turkish and Persian primarily, but then expanding towards other languages. And the this presentation follows. Okay, so this presentation has five short parts that build up on one on the other. The first part is defining the problem. So where does this idea come from? The second one is what is our approach as a team in solving this problem, at least attempting to solve this problem. And then Umar will provide a overview of the field, different approaches in this domain that we drove upon, and then we'll talk about our data set, how we've prepared our data set for to be able to run our experiments. So I will start with the problem. So this is from a recent book titled Literary Theory for Robots by Dennis C. Tannen. And the first sentence of the book reads, computers love to read. They read greedily literature of all time, all literature, all of the time, novels, encyclopedias, academic articles, private messages, advertisements, love letters, and so forth, no matter how insignificant. Our twist on this is that computers indeed do love to read, but they read only those things written and transmitted in machine readable form. And what that means is that computers can only, AI models, any sort of like any algorithms, they can only process text that has been made available in a machine readable format, such as a text file, a Word document, what would have you, but not images of text unless there's an OCR. Which means that OCR is actually like the optical character recognition or handwritten text recognition, HTR, are the bottlenecks that prevent many, many languages of the world, many scripts, many texts that only exist either in undigitized form or if they're digitized only as images for being able to actually be processed by computers. And specifically, what we looked at is this problem of bottleneck of OCR coming out of Ottoman studies and Ottoman and Middle Eastern studies. So here's like a more detailed description of the problem. The Ottoman, well, the Turkish State Archives, Directorate of the State Archives, the Ottoman Archives Department, which holds the largest collection of Ottoman Turkish documents left from the 600 years of empire, in currently in Istanbul. So there are about 95 million documents and about 400,000 registers that are ranging between 300 and 500 pages each. And a large majority of these holdings, there have been projects in the archive itself to digitize them. In many ways, the primary form to access these documents is through their digitization, through their scanning. But there is no OCR that would make them searchable, the way that like Google Books is maybe familiar to you as a searchable system where you can conduct a keyword search. And with that in mind, we trying to solve like this question of how do we get from an archive that has digital images but no text extraction possibilities. We've approached this problem as a question of multilinguality and non-English research in digital humanities, in NLP, and in AI more broadly. And we have two motivations for using a multilingual approach coming out of the practices and the history of the field of Ottoman Empire in the Middle East. And one of them begins with the question of like this field, like Ottoman Empire and the Middle East. What do these fields actually have in common? And it is a script. These are historical documents. On one side, on the side, you have a late 19th century Arabic script court document, and on this side, you have an 18th century Ottoman court document. Oh, sorry, Ottoman state document. So they're both written in Arabic script, despite of differences in the script itself. But then, in terms of our field-specific practices, when we are transcribing Ottoman Turkish documents, turning them machine readable by typing it up, which is a part of the scholarship in this field, we transliterate Ottoman Turkish texts, but those working with Arabic text actually transcribe them in Arabic script text. So what ends up happening is that it adds a layer of differentiation within the field that is also based on the script. So our multilingual approach, actually, instead of trying to get an OCR that works for Ottoman Turkish and transliterating into Latin script and leaving out like all of the other languages that use the Arabic script, historical languages of the Arabic script from this era, we try to tackle it as a way of looking at it as a script to text problem. And also, this is based on research in machine translation and research in other like sort of examples of HTR projects like Transcribus's Latin script M1 model, Titan 1 model. These have shown great potential in actually having a multilingual training out of a script-based joint effort. And also, we do need larger data sets. So our research deals with a um, more recent deep learning era, like transformer models, and larger data sets are more useful. And combining languages, especially like Arabic, which is a modern language that is still spoken today, that has like more data and more sources available, combining the powers of that to solve the historical problem actually enables us to take better advantage of these technologies. And also, we are really aiming to understand these questions of technology actually as a part of a broader field that could also join with broader fields that are using historically, well, they're using Arabic script historically, different languages in South Asia will come to mind. And that could be like this is a new vision for like solving technological problems of this domain through a joint approach as opposed to like doing separate projects for separate scripts or separate languages. And this is our proposed pipeline. So we would have the document. This is an Ottoman Turkish document, an example. And then there would be a machine readable Arabic script text, which could be the end stage for many languages that only use the Arabic script. But then there's the possibility of transliterating. And this way, actually, the problem gets divided into two separate technical tasks. One of them is an image to text transmission, and the other one is the text to text transmission. And splitting this up that way could also make it easier for computational aspects. And now I will pass the mic on to Umar.
Awesome. Thank you, Merve. And as Merve outlined, we're really bridging together two distinct fields here through this multilingual approach, essentially archival analysis as well as computational linguistics. And really, this is further characterized by current projects and initiatives in the field. And specifically, we're just going to go over three here that I'll briefly cover. They're the Digital Ottoman Corpora, efforts by the British Library, and finally, the efforts by the OpenITI eScriptorium. So yeah, with that said, let's get started looking at those. So yeah, the Digital Ottoman Corpora is a pioneering project which analyzes and engages with Ottoman Turkish texts from the 19th and early 20th centuries. And essentially, their pipeline has three main components. Number one, developing HTR tools for Ottoman Turkish. This is artificial intelligence-based text recognition. Two, crowdsourcing through leveraging the power of community, which is great, especially for a low resource language like Ottoman Turkish, broadening participation. And then finally, they have a digital editions project, which publishes selected Ottoman Turkish works on an open access platform. Now we can move on to some of the work the British Library is doing. Specifically, RASM, which is led by the British Library, is an initiative aimed to develop solutions for accurately and automatically transcribing extensive digital archives of historical Arabic handwritten manuscripts. So the goal here was to enhance accessibility by enabling full text search and discovery, as well as facilitating large-scale text analysis. And since 2012, they've actually also been in partnership with the Qatar National Library, and they've helped to digitize over 75,000 images of Arabic manuscripts over there, which is great. And then finally, the third initiative is the OpenITI eScriptorium. So this is an initiative, it's a multi-institutional project aimed at developing digital infrastructure for the study of Islamic cultures. And it focuses on creating a comprehensive machine-readable corpus of, pre-modern texts in Arabic, but also in Persian and other languages that are pertinent to the Islamic civilization. And its objectives are mainly twofold. Number one is corpus development, right? Generating a big corpus with all these languages, and then two, standardization. And actually in this very conference, my co-presenter Merve, she presented in the Global DH Symposium in 2021 on Ottoman HTR using Transcribus, which was using the same platform as Sufan Kiramitsatlian, the project for the for the previous projects that we looked at. And there were a lot of mutual synergies between their initiatives. And our project is kind of going in a different direction, but because we're really inspired by all these things happening in the computational linguistics space. And so with that said, yeah, let's maybe get into some of that. And let's start with TROCR. So what is this? It's a transformer-based OCR model that combines a vision transformer, which basically analyzes images, with a language model, which helps to predict text. And this offers, a more holistic approach. And it was initially trained on printed English text and fine-tuned on like English handwriting. However, our goal is like, hey, maybe we could adapt this script and use new scripts and styles through additional training. And in our work, we want to use TROCR and Arabic Persian scripts, building, on prior success with the English adjacent alphabets like Danish that we found, or that Peter actually worked on. And so what we found, though, is that adapting TROCR to these scripts required deeper customization, which we'll get into. So next, we see that in just the past year or two, Arabic and Persian writing has advanced rapidly, moving limited tools to impressive open source models and data sets. And you could see that with some of the work from North Carolina State University, where they were working on the HotFormer, which is basically a transformer-based model adapted for TROCR. And then next, we also see there are a variety of ways HotFormer improves historical Arabic handwriting recognition. And we see like it has gains of 51% accuracy over previous models. And some, you could, if you have additional kind of, we have like additional kind of information on that, which you could ask maybe in the Q&A on like what type of methods they use to kind of, lead to these successes. And then finally, Galam, released in 2024 by UBC, combines, a vision encoder with a Roberta-based language model to improve the recognition of, various Arabic, linguistics, handwriting styles. And, it's very state of the art on both modern and historical data sets. But without further ado, let's get into some of the work we were doing quite briefly, specifically when it comes to the training or the pre-processing, the training and the pre-processing of our text. So we have two data sets at the center of our projects, which is basically the cut data set and then also the, data collected from, other, Osman Aga sources, etc. And we see that there are a bunch of, HTR data sets, which we could see kind of in the list here that we have. And essentially, where our goal here is kind of how could we leverage all of these different data sets to kind of build a big corpora for us to train on. And so, and we also mentioned like we're not just using Arabic data sets, but also Persian data sets as well. And as you can see, beyond Persian and Arabic, we're also using like Ottoman manuscripts in our training set. Now, the big problem here is really the pre-processing. And so really briefly, before we actually train all this incredible data, we need TROCR to help configure the data and get it into a standardized, single line manner. And so we developed actually a 4-step pipeline in order to best, kind of convert those raw scans into that desired line by line, format. So step 1, which we can go into, is actually, reading the document scan. And to do this, we basically use a corresponding XML file for each, manuscript or each page that gives us 2 key pieces of information: the location of each line on the page, and then the ground truth of each line. Then after that, for our next step, we move to line by line segmentation. How do we actually take this information and split the image into its individual lines? And we basically use the data from the previous step and create a page-wide mask for each line as shown above. Finally, on the second to last, our next step, we have the line images, which we need to apply some additional masking on. And this is in order to remove the steep gradients that the previous algorithm created. And this helps during the training process. And then finally, for our last step, we apply a process called dewarping. And as you can see, the lines at the moment are not very straight and horizontal, but we can introduce some, mathematical, approaches in order to kind of dewarp and straighten these lines. And so finally, for some experimental results after, going through the training process, which includes model data preparation and model configuration, then it also includes training and fine tuning, we finally see kind of like what our results were. And essentially, on our test set, we received two kind of key metrics that I think help tell the story: the character error rate and the word error rate. And essentially, we've reduced the character error rate to 38.4% and the word error rate to just below 50%, which, I think for, Ottoman Turkish languages and scripts is a really great kind of step forward in progress. And as we kind of use more and more data sets in the future, then we train on these models, this could only get better and improve the accuracy for not just Arabic and Ottoman Turkish scripts, but all, non-Western or non, traditional scripts with low resource data. And yeah, finally, yeah, feel free to take a look at our working paper on SSRM. It recently just got published. So if you want any more details, feel free to ask us in the Q&A, but also be more than happy to check out kind of our work there.
Yeah. And I also want to quickly add, and we would like to thank Nora Barakat and Next Generation for allowing us to use their manually created data set of transcriptions of Arabic court records from 19th century Ottoman Jordan. And yeah, that was the basis of some of the data preprocessing that you've seen here. So we're very grateful for their support.